All right, we're going to pick up with Chapter 1, Section 3. We're going to be transforming linear and absolute value functions. We just finished talking about transforming the parent functions. We learned about the four parent functions, the constant, the linear, the absolute value looks like a v, and the parabola or the quadratic looks like a u. We learned what those parent functions were, and we transformed them, and we recognized the changes from the parent to the what we'll call the kid, the thing that has been transformed. Here on the screen I have a transformation cheat sheet for you. This is using vertex form of the equations. And when we look at this, if we take the parent version that you can see here in both absolute value and quadratic version, okay, and we add in the transformational information, which is the A, the H, and the K. And if you notice, they're about the same place in each one of them. The A is outside the absolute value of the parenthesis, the H is inside with the X, and the K is on the outside. A tells us two things. It tells us if there's a reflection. If A is a positive number, then it has not been reflected. It continues to point up as it normally would, like the parent. If A is negative, then it is pointing down. It has been reflected. If A is bigger than 1, it's a vertical stretch. It gets skinnier. If A is between 0 and 1, then it is a vertical compression or a vertical shrink, and it gets wider. To translate left and right, up and down, H, K is your vertex. That's the bottom of your V or the bottom of your U for your parabola. You want to center your XY chart around the H and the K. Now, there's some tricks to the H and K, but generally, most of the time, as long as there's not a number in front of X, you can take those numbers straight out and put them in the middle of your XY chart and chart a little left and a little right of those. H is the tricky one. H for horizontal, H and H match up, but you have to take the opposite sign. There's already a negative in front of the H, so it changes the sign of whatever H is. So I always think of it as opposite to get out. If you hop out of the absolutes or you hop out of the parentheses of the squared, you've got to opposite the sign that you're dealing with. K, on the other hand, is K for keep. Keep the sign. It's a vertical move up and down. It was over by the Y, but we've already moved it to the other side of the equals, which changed its sign for us already. And I've got an example down there at the bottom. It tells you how to apply all of those pieces. Now, if we bring that into Lesson 3, transformations of linear and absolute functions, that will kind of help us know where to put what types of transformations they're talking about. We're first off going to talk about translations. Translations up, down, translations left, right. Left, right is the horizontal. Okay, so we're going left. And if you notice in here, it takes the function y equals f of, instead of x, it's x minus h, because h is horizontal direction and h is in there with the x. So we're going to change the x before we calculate the problem and find out what the y is. Same with the vertical, but vertical is on the outside of that. Okay, horizontal's in with the x because it goes in the x direction. K is on the outside in the y direction, closer to the y, if you will. Okay, so let's look at how that looks. If we let f of x equal 2x plus 1, in problem A, a little extra line there. In problem A, they want us to write a function g whose graph is a translation 3 units down of the graph of f. So I'm going to do g of x equals, now here, up and down is the k direction. So that's on the outside. So I'm going to do normal f of x, and then I'm going to add, oh, nope, not add, because down is negative 3. And you might ask, well, why is it g of x and f of x in the same one? Well, because we're using f of x and we're going to move it down 3. And that's on the outside, as we just saw on the last slide. So then what I'm going to do is I'm going to replace f of x with what it's worth, 2x plus 1. I did that because f of x and 2x plus 1 are equal. So I just replaced the whole f of x thing with a 2x plus 1. Now mine is named g of x, and I can get rid of these parentheses because there's nothing to do inside them, and there's actually a 1 out here that I can distribute in. It gives me 2x plus 1. The minus 3 is at the back. The like terms of the plus 1 and the minus 3 That leaves me with 2x minus 2. And I have written an equation named g of x that has been moved down, that is f of x moved down 3. Okay, and if you notice, we went from plus 1. If you go down 1, that's at 0. Go down 1 more, that'd be negative 1. Down 1 more, that'd be negative 2. And that's where we are right here. Now b is a little bit more tricky. I'll do b in a green color. B is we want a function h of x whose graph is the translation is 2 to the left of the graph of f. Well, 2 to the left is I'm going negative 2. That's what my h is. Here, this was negative 3. That was my k. K, keep the sign, put the negative 3 right in. H is going to be different. I'm going to do f of, and remember it's in with the x, and it's already x minus, and when I plug in negative 2 for h, negative, if I have minus and negative, what that actually is positive. And remember, it was opposite to get in. So if it was negative 2 on the outside, when I go inside, I opposite the sign in there with x. Okay, so now I'm going to take h of x is going to be, now I've got the 2 from the original. Now instead of x, I'm going to put x plus 2, and then that plus 1. Underline all the original pieces. This is an original piece. That is an original piece. We have changed this part. Because we're doing f of x plus 2, we plug that in for x instead of just f of x. Now we simplify. The 2 can go into both. So h of x equals 2x plus 4 plus 1. H of x equals 2x plus 5. That's my h that has been translated to the left. And you might say, well, what it looks like is you went from plus 1 to plus 5. It looks like you just went up 4. And we did. But going up 4 also helps us move back to the left by 2 with the slope of this graph. If you graphed this line, starting at 5 and then going down and back, down 2, back 1, down 2, back 1, you would hit at negative 2 on the x-axis. Okay, so that's just translating, and that's the a, h, and k. Go ahead and click back to that slide for a, h, and k. Write that down, study it, memorize it, know how it changes it. That's going to help us out a lot when we talk about